What exactly is NASA looking for in the ocean's depths? Yes, 10 kilometers beneath the surface of the ocean. What hidden mystery lies deep beneath the water that NASA is trying to unravel? NASA scientists embark on special missions like Project NEEMO, which stands for NASA Extreme Environment Mission Operations. For weeks at a time, these scientists live and work in an underwater research base. And that's not all. NASA also employs a remarkable autonomous underwater vehicle, Orpheus, that dives to 10 kilometers below the surface to conduct valuable research. But why is NASA so focused on exploring the deep ocean? After all, the United States already has NOAA, a dedicated organization for ocean research. So has NASA uncovered signs of extraterrestrial life beneath the ocean? Or could Earth be on the verge of a significant disaster that NASA scientists are aware of and preparing for? A well-known geophysicist, Edward Bullard, once said, "Two-thirds of Earth's surface is covered by oceans, yet we know more about the Moon and Mars than we do about our own oceans." This statement reflects just how challenging it is to research the ocean floor. Despite this, NASA has set an ambitious 2-month deadline for this unique ocean mission. What's going on that's prompting NASA to work under such a tight deadline? Let's explore what's driving these scientists and whether we should be concerned. Currently, NASA is gearing up for a mission that is both high risk and high reward, one that I've been eagerly anticipating for the past 6 years. Take a look at this. Around 90% of ocean life exists in the sunlight zone, the shallowest part of the ocean. Why is that? This small illuminated section is home to the majority of marine species. As you descend deeper into the ocean, the pressure increases exponentially. For every 10 meters of depth, the pressure increases by 1 atmosphere, which is the same as the pressure we experience at Earth's surface. Remember the tragic incident with the Titan submersible? The submarine was about 3.5 kilometers deep when it tragically imploded, vaporizing its passengers in a fraction of a second. They didn't even feel any pain, as the brain takes about 25 milliseconds to register it. However, NASA is planning a mission that will take them 3 times deeper than where the Titan incident occurred. Why? Because NASA is preparing for a monumental mission, one that will involve searching for alien life, but this time within our own solar system. They've already detected signs of alien life there. Now, they just need to confirm it. But what is this mission, and where is NASA focusing its search for extraterrestrial life within our solar system? Let's dive into that in a moment. But first, why is NASA studying Earth's deep ocean to assist in this alien hunt? As you know, life on Earth originated in the deep ocean. This fact plays a critical role in NASA's quest to understand life's potential elsewhere. NASA scientists have identified 3 essential ingredients required for life to exist: water, energy, chemistry. No matter how technologically advanced we get, at the core, we are all made of atoms that are not alive. Elements like carbon, hydrogen, oxygen, and sulfur are critical for life. When these elements interact, they can trigger chemical reactions that lead to the formation
are critical
of life.
for life.
But does simply combining these elements automatically create life? It's like trying to make tea with tea leaves, sugar, and ginger. Just putting them in a pot won't do the trick. You need a medium, water, an energy source, heat, fire. Similarly, in Earth's early days, these elements needed water and energy to come together in the right way. But how did the deep ocean get its energy, considering sunlight doesn't reach that far? Well, here's the surprise. Life didn't originate from sunlight. It came from Earth's internal energy. That's why NASA is investigating the Hadal Zone, a specific deep-sea region where life may have first emerged. What exactly is the Hadal Zone? And how is it helping scientists decode the origin of life? The Hadal Zone is the deepest part of the ocean, extending to the ocean floor. It can reach depths of up to 11 kilometers in certain areas. Within this zone, you'll find hydrothermal vents, underwater volcanoes that spew hot water, minerals, and steam. The water released from these vents can reach temperatures as high as 400 degrees Celsius, hot enough to melt metal. It wasn't sunlight that powered the emergence of life on Earth, but Earth's hot core. The geothermal energy from these vents contributed to the creation of complex RNA, which eventually led to the development of the first single-celled organisms, bacteria, and viruses. Over millions of years of evolution, these organisms became the complex life forms we know today. This is how life began on Earth. Inspired by this, NASA is now looking to apply these findings to other celestial bodies. But where exactly? Mercury is too close to the Sun, Venus is too acidic, and Mars is still being studied. But there's no liquid water there yet. The gas giants like Jupiter, Saturn, Uranus, and Neptune don't have solid surfaces, making them unsuitable for study. But what about their moons? One moon stands out as a prime candidate, Europa. Europa is Jupiter's fourth largest moon, and according to NASA's findings, it has an ocean of salty water hidden beneath its icy surface. NASA's Voyager and Galileo missions provided critical data that confirmed the presence of a subsurface ocean. Europa's icy surface is continuously stretched and compressed due to Jupiter's powerful gravity. This process, called tidal flexing, generates immense geothermal energy that keeps the subsurface water in a liquid state. From magnetic field readings, NASA has also confirmed that a global ocean of salt water exists beneath Europa's surface. What's even more exciting is that Europa's ocean is estimated to contain twice as much water as Earth's oceans. Plus, the presence of geothermal energy in its core could allow for hydrothermal vents similar to those on Earth. Moreover, Europa's surface and environment contain the same fundamental elements that could support life, such as carbon, oxygen, hydrogen, and sulfur. That's why NASA is sending a space probe to Europa to search for signs of alien life. This mission is one I've been eagerly awaiting for years. This is no ordinary mission. It's a groundbreaking one that will inspire space agencies across the globe. To give you a comparison, think about the Chandrayaan-3 mission. While it was a remarkable success to reach Europa, NASA is planning an even more complex journey. Europa is about 1,600 times farther from Earth than the Moon. Imagine the Moon being right next to you, and Europa being the distance between Mumbai and Delhi. On its way, the spacecraft will be affected by the gravity of massive gas giants, as well as gravitational interference from moons, asteroid belts, and solar winds. This mission will require incredible precision and navigation, but it's going to be spectacular. NASA's Europa Clipper satellite is set to launch by October 2024. Once launched, it will use a gravity assist maneuver around Mars and Earth to gather speed before heading to Europa. It will take about 7 years for the spacecraft to reach Europa, with every step carefully calculated. When the satellite arrives in 2031, it will begin studying Europa's surface, atmosphere, and other characteristics. And once it reaches Europa, NASA will deploy cryobots, robots designed to melt through the thick ice and investigate the composition of the ocean beneath. These robots will be powered by nuclear energy, carrying smaller robots to swim and search for signs of life. Just imagine, what if we find alien life there? What would its biology be like? Would it confirm that we are not alone in the universe? What do you think the chances are of discovering alien life in Europa's ocean? Is there a possibility we could find extraterrestrial life? It's important to remember, so many space agencies are working together on this mission, and Europa is closer than we think. We have powerful tools like the Kepler Space Telescope, Hubble, and the James Webb Space Telescope that help us look for life far away. Yet we still haven't found concrete evidence of life beyond Earth. And while we base our search on Earth's life model, there could be other forms of life that have evolved in ways we don't yet understand. But even if we don't find life, this mission is about more than just the outcome. It represents the best of humanity, the curiosity, the determination to explore, and the desire to push our civilization forward. Curiosity-driven missions like this not only inspire us, but they also lead to new innovations that benefit every aspect of our lives. So let curiosity lead your life, because there's always more to learn, explore, and discover.